Okay, so I hope you guys can hear me very well. So my name is Cyril. I am one of the team members at Zindua. I'm more versed in data science actually. So I was the technical mentor for data science for the longest while. Though now my focus on the Zindua team is on operations, which is fine. So data science is my core focus, and I'll be taking you through the data science pathway today. So we'll get to understand just what are the skills you need to learn, how can you break it down, what exactly is data science in the first place, for those who are getting started as well. And we just want to get a general breadth of data science, how you can start learning this data science as well. And then you can have the freedom to explore. We have a free intro course in data science for those of you who want to take it later on or explore more advanced science if you want to go in for the core program as well. As I'm recording this, I'm struggling to find a way to make this screen full screen. I know on your end it is full screen, but for the sake of the recording, I am struggling a bit. I don't know how this is going to be. That recording would have a very, very small screen on the side. So let me see what I can do on this front. Anyone with ideas on how to do on how to structure it such that the presentation only one person is being seen? I think you pin it. Let me see. If I pin it, okay. Okay, that is. I think I'll learn the breadth of it as I keep doing such Google Meets. I just want to find a way to make sure it's full screen, but that's the best that we can go for right now. All good. We can't complain about it. Okay, so let us get started today. Uh-huh. Okay, I'll skip there, and then we can get started proper here. Uh-huh. How do we go more full screen of all this? That is fine. Just bear with me, even though the sort of recording will not be as full screen as we expect it to be. But those of you who are in the workshop should have a really clean view of everything in that regard. Awesome. So let me just go through what you're going to cover today. I've already introduced myself. So today we're going to first of all look at a general introduction to data science. So we'll be covering some of these questions over here. What is data science? What are the pillars of data science? What is the typical data science life cycle? This will be more of like the structure of typical data science projects. And then we'll explore some applications of data science. In fact, I'll just start preparing what possible applications you've had of data science right now, as that when we get there, it becomes it makes sense for you guys as well. And then the most important part of this particular session is going to be going through the data science roadmap. And we've broken down the roadmap into three things particularly. So the first layer is going to be data analysis, the data analysis layer. So if you want to become a data analyst, what are the core things you need to learn to become a data analyst? The second layer will be now for those who want to go beyond data analysis and they want to become data scientists or machine learning engineers. What machine learning concepts are you supposed to learn to be able to get that sort of next level job that involves more predictive analytics or rather machine learning modeling on that particular front? And then I'll also expound on additional pathways that you can explore beyond machine learning, and this I will term as the advanced data science layer. And this will be for people who want to do further specialization beyond just typical data science on what they can take it. And after that, I'll be able to share the next steps for most of you, whether it's Zindua School and what we're able to offer on the data science curve. And we'll also share more about the free foundational course that we offer for data science covering Python that can allow you guys to get started in data science for those who are ultimate beginners on this particular front. Okay, so far so good. If there's no question, we'll get started. If you feel like there's something that you'd suggest me to go through in the course of that of this call as well, feel free to type it down on that meet as well, and then we'll give it some time later on in the call as well. Once again, because I am not on the Google Meet screen, just let me know in case I go off. Though I'll just put my phone on this particular front so I can make sure that I'm always in the call at all times. So that should be okay. Okay, how do I go full screen on this one? That's fine. That's as full screen as I can go. Okay, so let's start off with what is data science? Anyone wants to try on what they think data science is? Anyone? Any attempt? Okay. Uh, Everyone's an ultimate. Feel free to type down on the chat on what you think data science is. Try and change the layout. Not sure if it will work. Thank you very much, Victor, for the suggestion. I think on the recording now I have something that's slightly more full screen, so that should be okay. That's fine. Thanks for that. Any ideas on what is data science? Umi, feel free to tell me. According to you, what do you think data science is? What does it involve? Just based off of your exposure so far, so good. How about Stephanie? I don't know if we can hear from you. Any exposure to data science? What do you think data science is? Before I introduce my very nuanced explanation. Okay, it is a silent call today, so that's a bit sad. I hope we can get energy as we explore more of these things later on. But I'll go ahead and state that uh, okay, so I don't want us to focus on the definitions here. I just want us to focus on the understanding of the concept in the first place. So just from the name data science, you can see that this already involves data. And in the realm of data science, we're going to it's going to focus so much on complex analysis of data. Even simple analysis, we can call it data science, but it's going to be more of the more complex analysis of data, and we are doing this analysis for three core reasons. And I think this is very, very essential to understand, so that you understand why we have data scientists in the first place. So the first thing we're trying to look for in this data is to figure out if there's any unseen patterns in the data. So that's one particular thing. I'll try give examples. I'm going for it. The second layer is we're trying to derive useful information. That's why we're seeing data science being applied a lot in businesses. Businesses are trying to derive useful information from the data the business has collected over the time so that they can be able to make better decisions for their business, right? So if I'm collecting data on my phone from time to time, so let me work with number one, right? So let's say I'm using my phone. This phone of mine is collecting so much data on a day-to-day basis, minute-to-minute basis. I have like 50 applications, 80 applications on my phone. I do different things. Probably when I do my complex data analysis of this, I'll be able to see unseen patterns such that from this time to this time, I am avidly a consumer of YouTube, or this is the amount of time I waste typically going through social media and the likes. So if I was to just look at the data analysis of my phone, given the different ways it kind of collects data from me, which is pretty much my usage of the phone, I can start seeing some unseen patterns, which I usually don't know of how I use the phone or how much time I waste on a typical day. So that's a good example of how data science, so this is a very small scale where I'm just looking at my phone, can detect unseen patterns in my own personal life. The second layer is now to derive useful information. If we have a business like Java that has opened coffee shops all across Nairobi, let's think about it. They're collecting sales data of these coffee shops all through, right? So they know in CBD, this place, Monrovia Street, we have a coffee shop that does this amount of sales on a day-to-day basis. This number of customers come in at this particular time and then they leave, and all that kind of stuff. So if we do the analysis of their sales data, which is grouped per branches, we look at the times, we look at the frequency, we look at the revenues we're getting off of this, and the cost of rent for this particular things, then we can start deriving useful information by trying to look at the profitability of each and every single branch and determine where we should either open the next branch. So what's these high traffic areas that have a lot of business that should be closer to where we should open our next branch, or decide what branches we need to close because they are doing extremely poorly as compared to the other branches. So that could be useful information that Java would want to deduce if it was able to analyze data collected from all its stores or cafes across Nairobi, just as an example. And the final thing is now to make predictions and decisions. Now, I'll use a slightly more complex example over here. Let's say someone is a trader, right? They've been tracking stock markets for the past 5 years. They've been able to, first of all, find unseen patterns. Secondly, they've been able to derive useful information such that when this company gets to summer, so this is an ice cream company. So whenever it's hot, right, summertime in the US, they have an influx of sales, and this is now Q2. the summer is about to come in, so we expect an influx of sales to come in. So they've been able to derive this useful information by analyzing the past data of this particular company. Now, what they're going to use data science for is to make a prediction on what the stock price of this company will be based on their previous data analysis. Now, this is a more complex example that we see applying to, let's say, financial markets, but it doesn't always have to be financial markets. A good example is you could be a real estate agent, right? Someone has given you a house, and you've inspected the house and you've written down the features of the house. Like, it has 3 bedrooms, it has really good lights, there's a high ceiling. So you've written down all these things. You realize that when you write down the features of the house, you've come up with a page of about, let's say, 200 different features that we look at. But because you've been in the real estate industry and you've done data analysis on this, you already know the typical features of a house, and you've just been ticking check boxes for that particular house. And now, using machine learning and previous house data and the prices that you've been able to quote for, or you've been able to see being quoted for these houses with different features, you can now use the features of this house to go ahead and determine what will be the selling price for the house that you've just inspected. And this is one good practice project that we see a lot of data scientists work on as well, which is the house pricing data available on Kaggle. That is a typical example of how data science is being used to make predictions, whereby we analyze features of houses and the prices of these houses over time, such that the next time I'm just given the features of a house, I'm able to deduce what is the expected price of that particular house. So quite essential in that regard. And of course, this is going to be way more profound. We'll talk about healthcare, whereby after analyzing a lot of x-rays of patients with tumors, doctors are able to find a way where to predict whether someone has a tumor or, let's say, a cancer by looking at an x-ray, and they're able to detect this slightly earlier, because at least the data science are able to see patterns that your clean eye was not able to see before, right? As we start using a deep neural network, which is now the artificial intelligence layer, some patterns that typically doctors couldn't see with their usual eye, now the data can deduce, right? Because you can see the pixel change in these x-rays even to the smallest degree, such that they can make these predictions early on when some of these things are slightly more curable. So you can start seeing it even for more complex industries. It's a very, very essential there. So that's what we'd summarize it science are. So one, data is very, very important here. Second is we are analyzing it, and these are the 3 reasons we're analyzing it for. Any questions so far, so good? Okay. Now, to better understand data science, the best way to look at it is to explore what we call the pillars of data science. And we have 3 particular pillars of data science, and I'll explain how they all blend in into, I don't know what this is what people call a Venn diagram. I hope I hope I'm not massacring the word Venn on this one, but let's call this our Venn diagram over here. And from the Venn diagram, you can see that there's 3 fundamental layers that matter to data science. The first layer is mathematics and statistics. There's no data science if you're not doing math and stats in the first place. First of all, this analysis of data is based off of statistical concepts, right? It's statistical methods that we're using to analyze this data, so that we can make hypotheses and see whether our hypotheses check out or do not check out. That's the first layer. Second layer is we are using mathematical algorithms. So some of the things we are running on machine learning models, they're based off of mathematical concept, calculus, linear algebra. At the end of the day, we are applying matrices and vectors on this sort of data, applying a bit of linear algebra of it on it and calculus to be able to run this machine learning algorithms. So when you have a good understanding of both the mathematical side and the statistics side, it becomes very, very easy to understand how some of these machine learning algorithms work, because they're extremely mathematical. How they're optimized to find the best fit or to make the best prediction is entirely based off of math and definitely statistics. So people with a math and statistics background, highly recommended to start thinking about data science, because this is pretty much statistics on steroids, as some people like to think about it. The second pillar is now the computer science layer. So in typical statistics, we know our statistical methods, and then we go and use a statistical tool like Microsoft Excel or Stata, for those of you who are more into academia. And then in the recent past, is starting to see R coming up. But R is a programming language, though statistically focused. Because we are trying to find a way to deal with mass amount of data, and we're trying to do very, very clean automation, um, the computer science layer becomes extremely important. We've implemented all these statistical concepts, right, and mathematical algorithms in a programming language so that things can become more customizable and more automated, and so that computers can do a lot of the learning by themselves. So the second pillar of data science over here is the computer science layer, where you need to learn a programming skill because you're using a programming language to effect or do the modeling or do some of this analysis over here. The two most common languages we use for it will be Python, which is by far the most profound language on this particular front, and R programming, which is more used in an academic setup. Awesome. Now, when you just have math and statistics and computer science, that's pretty much machine learning. The entire layer of machine learning is whereby we've been able to embed programming concepts onto statistics concepts so that we can make predictions and detect this unseen sort of patterns in data as fast as possible. That's the machine learning layer of it. Um, However, without the third layer, which is domain expertise, then there's no data science whatsoever. So domain expertise is understanding that we are not analyzing data in a black cave. We're analyzing data that's pegged to a particular domain. Doctors are trying to analyze data from x-rays of patients, right, to be able to predict whether someone has a particular disease early on, let's say brain tumors, for example, and they want to say whether that tumor is malignant, or there's another word for it. Is it usually malignant versus what? Something else. Once again, not so much into the medical stuff of it, but there's also a really good test project on that particular front. Yeah, benign or malignant tumor, a good example. It's a typical question doctors are trying to analyze on a typical day-to-day basis. If I'm the best person in math and statistics and I'm very, very good at programming, right? There's nothing I'm going to deduce off of that data if I'm given a couple of x-rays if I do not have a medical background off of this particular thing. Now, I know with some of this practice data, like a lot of the heavy lifting has been lifted for you, where they've been able to do the matching, they did a lot of the thinking and the problem setup early on. But in the initial phase, where we were even trying to think about how we collect data, right? What type of data we'll be collecting, how we'll be collecting it, what data can we do without, and the likes. If I'm not coming from a medical background, there's nothing I can do there. So the best I can do is just be given data and try to optimize my algorithms as much as possible to make a good prediction. But without that domain touch, there's no much more I can do in regards to improving that data to get a better output. That's why we're saying data scientists should also have a domain focus or domain expertise to make their skills make sense. Now, this is extremely easy for some because business is by far the most common skill for a lot of people. So a lot of people end up practicing data science in a business setup, things such as sales analysis. For people with a financial, which is more of an in-depth finance background, then they'll end up applying data science in more finance cases. That's why you end up seeing quantitative analysts, people who are practicing data science deep into quantitative analysis of stock markets and the like. So they're working for hedge funds to be able to do some of these predictions. So those are people with in-depth knowledge on that particular thing. Software developers are a good example of people with domain knowledge on product development. So they can apply data science on trying to do their product development to understand what features work for their users base and not, and all that kind of stuff. Now, let me just summarize this particular pillars of data science over here. When you only know math and computer science, that is machine learning. That's pretty much what machine learning entails, right? If you're good at math, statistics, and you have a domain expertise, that's what we see in academia a lot. You can end up doing a very good traditional research, whereby you collect your data, you run statistical models off of it, use tools such as Excel and Stata, right? Because you have domain expertise, you know what to do with that particular data, and you know what questions to answer with the data, and how to go about the data cleaning process and the likes. So let me just say that. Once again, a lot in academia. If I'm very good in a very good political analyst, and I know math and stats, then I can easily do polling, right? A good example during elections and the likes. When you only know domain expertise and computer science, then that's where we end up having people who are called product developers, or you can do product development. A good example is MailChimp. MailChimp is an email automation tool, right? That if I am just a programmer living in a silo, there's no way I can build an email automation tool. I need the domain expertise in marketing, and particularly marketing automation, to be able to build a product that solves this email automation problem for businesses. Now, if I do not have that domain expertise, then it's paramount that I'm working with team members who have that particular domain expertise, such that the code I'm implementing is coming from an expert perspective. We are building features that are informed by people who understand what the domain is all about. That's product development. And you start seeing how domain expertise is even very important in product development in itself, right? You don't build an insurance product if you do not understand insurance in the first place. That same applies to data science. The only thing we are adding here is the math and statistics. So when you combine all of them, that's now the perfect realm of data science. So it does not matter what career you're from. I think the biggest idea of this Venn diagram is to state that regardless of what career you're from, data science could play a role for you because data is essential for almost all fields in the world today. And by getting a data science skill, it means you can start doing more complex analysis within your particular domain, or start improving your breadth of understanding of your particular domain, because now you can do more complex analysis that's better than typical traditional research, or you can get more advanced roles within your particular role. It's a good example of being a trader in a Wall Street bank for 5 years, learning data science, and then realizing you can start building algorithms to trade for people. So you could speak more value to your company based on your domain expertise. So this is not a way for you to run away, right? This is a way for you to improve more on your domain. But it could also be a way for you to run away to a different career if you just want to go ahead and do data science in a different purview, right, and the likes. But the domain expertise will still help you to a significant degree. That's probably the thing I stress a lot when I'm talking about the pillars, because in a typical program, we'll go through computer science, math and stats, machine learning pretty well, but we don't really focus on domain expertise because we can't teach people how to be doctors, to be salespeople, and the likes. And that definitely comes from their backgrounds before. Okay. Any questions so far so good? As I look at the time now, we have good time. That's fine. If you have a question, feel free to drop it on the chat as well. I'll be looking at the chat once in a while. I don't know what happened to my presenter view. I hope you guys can still see my screen. That is fine. Once again, let me just open the chat once over here. So no question, so far so good. But if you do have a question, feel free to cut me short and ask me the question. Now let's talk about the life cycle and careers in data science. And I'll focus more on the life cycle of data science in the first place. So someone has given me a project. And I'm going to use a project that's more in line with what you have right now. Let me think about it. So let's say I have a project such as I have gotten trying to use. Okay, so we just from an election period. Let me use that one. That's the low hanging fruit in my head right now. Someone has been able to give me polling data, right? So we've been able to do a random sample of votes across different constituencies all across the entire nation, right? And now we are supposed to predict who's going to be the presidential election winner at the end of the day. What will the life cycle of this project look like? Awesome. So let's talk about it here. So the first thing is we need to understand the business and problem understanding. Very, very important layer. So when you're trying to predict the president of a place like Kenya here, let's say during elections, such that you already have some data coming in, or before election, where you're entirely based off of polling data, we need to understand the problem. And when you talk about understanding the problem, you need the domain expertise to give you the right assumptions to make in this case. So a good example will be understanding that Kenya votes in blocks is a very fundamental thing to understand. So that you make sure as you're sampling out for the entire nation, you're able to put into account the different blocks and how these blocks are, how big these blocks are. Or probably if you're not going to put Kenya into regional blocks, you're probably going to put it into counties, right? And you know, like certain counties will have strongholds for different political parties. So you'd want your analysis to be based off of that particular business or problem understanding in the first place. If you do not know the political landscape of Kenya, then that will not come easy, right? But if you do, then that will be a very fundamental layer of your problem understanding, and you'll be setting up your data collection to understand that you want to collect samples of data per county, right? So that you can be able to make predictions per county, right? Extrapolate it to, let's say, the population in a particular county, because some counties have 1 million people, some have 100,000 people. So that also matters. So I'm trying to understand as well, there's this sort of county variable. So that's also a data point I need to think about before I can even think about making the prediction at the end of the day. Now, to understanding the problem, we now get to data collection and sourcing. The moment you understand the problem or the business understanding, it's very easy to know what sort of data you need. Now you're just worrying about where you're going to get this data from. This data could be readily available. Probably you just have to download it. Probably this data is not readily available. Let's say I'm doing an analysis of Jumia. I want to start a business tomorrow. I want to see what are the most on sale things, like things that go the most on Jumia, right? I don't know how I'm going to get that. Jumia is a very robust site. But because I'm a programmer on this front, I know I can scrape Jumia and output an entire database of 10,000 to 100,000 products in their catalog, do an analysis in regards to how many sales they've made or how many reviews they've made, so that I know the products that have the most reviews have the most sales. Probably I'm going to boil down and say these are the top 10 products or other categories that I need to be focused on. That's just a good example whereby my data collection, I can't download the data, but I need to think about where I'm going to get this data from. So I want to start a business tomorrow. I know Jumia is a place I can scrape to know what sales or rather what things people are buying the most, that I can start a business on Jumia tomorrow. So that's a good example. So you can download data, either CSV, JSON format, whatever format it is, or you can go ahead and scrape this data yourself from the website, where you have to code an automated way to get this bulk data because you can't do it manually. The third layer is you can connect to APIs. So there's people who already have databases of data that they have an open API access that you can access, of course, using code as well, right? So that you can be able to access bits of this data. Usually they give you a bits or a segment, of course, with certain rate limits based on that particular application. If I wanted to do analysis of Twitter, a sentiment analysis of how people feel about a particular, let's say we're back to the election problem, how they feel about a particular candidate, probably I'll go ahead and get into the Twitter API, sign up for the API, go ahead and collect data, which is tweets that have mentioned the name elections, or they've mentioned any of my presidential candidates, so that I can do sentiment analysis of them. So I'm using APIs for data collection. So there's different ways to do data sourcing and collection. Some of them will involve you programming so that you can be able to get them. Some of them will be the easier route where you already have data available for you, you download. And then the next layer will now be cleaning and preparation. How do we make this data ready for our models? I feel like someone has a question. If you have a question, feel free to ask me. If you have a question, put it in the chat as well. So regardless of where I get this data from, it usually does not come in the best format, right? If I'm scraping an entire Jumia website, probably there was pricing errors somewhere. My scraper was not able to put prices in numbers at some point. Let's say you realize that I scraped data, it also went to the Nigerian version of the site. So some of the units are Nigerian, Naira, the other ones are Kenyan shillings as well. So that's a bit of a problem for me because I want this analysis to be standardized, right, in one particular currency. So the first layer of my cleaning will be to look at that pricing column and figure out what sort of prices are in Kenyan shillings, what sort of them are in dollars, what other ones are in nairas. Can I go ahead and convert them to a standard currency and the likes? What if I have missing data on that particular front? So I'm doing my election analysis. I realized that after doing all this particular data collection, Garissa County, I did not get the number of registered voters in Garissa County. What do I do about it? Right? Those are questions we're trying to ask ourselves here. Of course, domain knowledge helps you answer some of this question, but it's your programming skills that allow you to clean this data in the most efficient way possible. And then we go ahead and realize that we have categorical data. And we know that our machine learning models we cannot just feed categorical data to it, right? We probably need to encode these categories. So if I was trying to classify wine and beer, and my categories are beer and wine, I know very well there's no mathematical way that can interpret beer or wine. So probably I need to encode this data as 0 or 1, so that when it goes to a machine learning model, it's able to output whether it's predicting it to be 0 1, because the 0 1 now we can run a mathematical concept on it. Let's say we can run a ReLU function, right, on the features to be able to output a 0 or a 1, and then that could be our classification. Once again, these are mathematical things that we get to cover when we get to machine learning, though not for this call. I'm just mentioning an example for those of you already in depth into mathematics, for example. Awesome. So we're going to prepare this data, set it up to make sure, one, we don't have missing values. If there's outliers on our data, we need to find a way to fix it. If we need to encode the data, we need to do it. If we need to standardize the data, which is bring the mean to 0. For those of you guys who are familiar with statistics as well as standardization, you also have normalization as well. These are things that we do on that particular front. Now, I'll skip data maintenance for now. but I'll go to the next one. As soon as my data is clean, I can now start exploring this data, doing quick analysis. I don't want to run a model or start doing predictions off of data I've not been able to analyze. So on that exploratory data analysis, that's where I start doing a lot of visualizations. I do summaries, what's the mean and the like. So this is typical data analysis. And then once I understand my data well enough, usually you output visualizations, you realize, oh, there's a gap here, I need to add more of this data. Probably my data does not answer this question so well. You don't know why you start discovering there's outliers you left out as well. So this is what you're going to do to the outliers and the likes. And as soon as you go through a cycle of data cleaning and exploration, up until your data is perfect, then now we can go to the data modeling layer. And this is whereby we start applying machine learning algorithms to be able to make predictions for us. We'll get to this. I won't expound more on this. This could either be we are classifying the data, probably we are running a regression, probably we just want to cluster and create segments of this particular data so that we know what to do best with it. That's a good example. And then after we do our modeling, we want to do our evaluation, right? How well is our model performing? What is the accuracy, right? At times you have training data that you want to evaluate it with that particular training data before you push your model out to the world and it starts making predictions. So if you already had house price data and the price of the particular house, I was able to model and get a regression line that can predict the prices of a house at any given time. So when I'm modeling this data, I'll take a small percentage of the data I already have and see if my model will predict the prices accurately and to what degree. This is whereby we start doing mean squared error analysis. We start looking at accuracy scores. If I'm doing a classification and the likes, all of things we cover when you're going through different machine learning algorithms as well. And then the final layer now is we've been able to create a really proper model that's able to do a proper prediction. Let's imagine we were working in YouTube, right? And in YouTube, we were able to create a model that's able to understand the interest of a customer whenever they go to YouTube. They were able to understand if someone watched this video, then they'll probably be interested in this. And we did a lot of that, and we did a lot of testing there when you're doing the modeling, and we served this other video to other customers or people within the same segment, and we realized that 90% of them end up clicking it, right? So after evaluating our model, we were very accurate that if someone watches a video by Citizen, they're likely to click NTV, right? Whenever they're looking at it as well. So now the next layer for us was now, because we know the accuracy of our model, we now want to push it live. So I'm working in the YouTube team now, and we now want to push our model live, integrate it with YouTube, so that it does it automatically, such that next time a user comes in, it's able to understand their preferences and predict the next video for them using the model that we had already created. So now, because we evaluated our model with data that we already have, now we're going to deploy our model so that it can start making predictions for new data onwards. We'll talk about that later on, right? And the final thing that's very important, whether you're going to be doing the model deployment or whether you're not going to be doing model deployment, at times people just want some data analysis. They want to see the unseen patterns in data. Data communication is very important. It is essential for any data analyst, any data scientist to be very, very good at communicating, because you're not working in a silo. You're working with a team of people. And at the end of the day, after doing all your coding, you've been able to create your Jupyter notebooks. Everything seems okay and perfect. The question is, people will want you to present to them, understand what insights were you able to get off of it. What decisions are we supposed to make as a company? What are things that we still need to do research on? And the presentation skill and communication layer is very, very important. And when you're done with all of it, right? The moment you're done with the cycle, you always go back to the beginning again. So I've done all this model deployment and the likes. I've realized, oh, the accuracy could improve. Oh, this data is not that perfect. There's something we could improve over here. We get certain insights off of it that we use these insights to frame the next business problem understanding, and becomes a continuous life cycle of a data science project that we keep improving over time, understanding more and growing it over time. A good example of people who work like this are driverless cars, where you see they create a model for driverless cars, they call it version 1, they get to the end, they realize that while they were driving these vehicles, it could not detect a zebra crossing. So they go create a second problem understanding, they improve the model to detect zebra crossings, and then they go test it. They realize when someone jumps on the road accidentally, they might be knocked, right? That kind of stuff. And it becomes a constant life cycle where we do all this collection, cleaning, exploring, modeling, we communicate, we deploy, and then when we throw it out there, we identify another problem, and then we keep improving it. Of course, this will be based on whatever project you're working on, so this might be different from time to time. Now, let me talk about data maintenance and model deployment. At times, at certain companies, we are working with large sums of data. Let me call it big data. That at times we have to automate the cleaning and preparation process because you want to do real-time processing of this data, or rather batch processing of this data. So if I created data cleaning, right, and I was able to put it into a pipeline such that next time, let's say I know how phone data comes. So I've been able to do cleaning of previous phone data. But I want for the future phone data, as I'm using my phone on a day-to-day basis, at the moment I use my phone again, this data is cleaned and prepared automatically and served to my model so that I can be able to output a prediction, right? So that I can be able to, let's say, predict the next YouTube video that I'm going to watch. So we need it more real time, or we need it slightly more automated. And that's where the data maintenance layer becomes very, very important. This now we're talking about data engineers on this particular front. So while you have to figure out the collection layer, you also need to think about the entire pipeline. Can I automate the collection, right? As soon as I collect the data, can I automate the cleaning and preparation, right? After cleaning and preparing this data, where do I need to maintain the data, right? Should I save it in a data lake, in a warehouse, so that other data scientists or machine learning engineers can have access to it and do predictions off of it, right? Or am I supposed to serve it to a place that a model can work on it immediately as well? So you're trying to think about the data maintenance layer of this. This is usually for more real-time applications on that particular front. And then you also have to start thinking about the model deployment so that things can work automatically, right? Right now, when I go on YouTube, it's not like someone is taking in my data and then going behind a Jupyter notebook and trying to make a prediction. They've already automated that entire pipeline all through, and that's the big value of data engineers. So off of this life cycle, you realize that you don't have to know everything, right? Though it's good to have a good understanding of almost everything, but you have to specialize in certain layers. What I've just talked about on focusing on the pipeline of data collection, data maintenance, and model deployment, that means you could be a data engineer. Those are the red zones, right? If you just want to become a data analyst, you're mostly good at the data cleaning and preparation layer, the exploratory data analysis, and the data communication. So you're more of the person who analyzes data and outputs insights, right? You don't worry so much about the pipeline of that particular data or how you can automate the collection layer and the maintenance layer. Though at times it's good to have a good understanding of that because not always will you have a data engineer in the team. And then the next layer is those of you who decide to focus on machine learning engineering, which is whereby you already have your data cleaned, or at times you have to clean your data and then you go ahead and model it and evaluate it. At times you also have to deploy it. But if you have a data engineer on the team, you probably don't have to deploy it as well. So these are people who are extremely vast on that modeling layer, right? You're able to create models that have very, very high accuracy, right? Or have very, very low errors so that they can make as good a prediction whenever they're deployed or pushed out to your data. And then if you learn pretty much everything that's in bold, that's from data collection to data communication. Of course, you can always skip data maintenance and model deployment because it's usually a domain for data engineers. Though I recommend knowing, then you can always be a general data scientist. And then you also have more specialized careers. So a good example is a quantitative analyst. So for those of you who want to understand this entire stack but want to work mostly in the financial market, so you could be a quantitative analyst, right? At times, you also have actuaries, so anyone who's an actuarial scientist, whereby because data is a very significant layer of the typical risk departments in today's world, you also have to understand it science to a significant degree to get certain actuarial science jobs as well. So I'll just keep that in mind as well. Any questions as we now get to the applications and go to the roadmap? Questions from anyone? Once again, let's not sleep. Yes, Jesse.
Yeah, I can see a question on the chat box. I'm not sure if you'd covered it before.
Okay.
I think it's Victor. I'm not sure if he's still on the call. Hope so. Yeah, he was asking a quick question. What would be more marketable? Yeah, he's here. What would be more marketable, computer science or data science?
That's a very, very good question. And it's very hard to answer that question because I always feel like both of these sort of career pathways are in demand in the market today. I would say computer science could have more demand because it's profoundly used across more companies, right? Whereas data science is more in demand in bigger companies because there's a shortage of talent in that particular space. It's still an area that a lot of people do not understand fully. So people are trying to look for experts. So in the corporate space, I'd say data science is becoming more of a need for them. It's very easy to get banks that are saying we don't have enough data scientists, right? It's not a common degree in a lot of universities as well. So that there becomes a problem to a degree. However, if we try to look at the sheer number of job opportunities out there, just knowing computer science, being able to do mobile development, software development, almost every company needs it, right? Even someone who's starting an e-commerce business, Kesho on a Shopify, needs like a web developer to help them do that, even before they think about the science layer. But then, because not many people are trained in data science, there's a significant need of it. So, once again, the answer I can give you on this is very subjective. Probably we can do scraping. That's part of the collection layer of job platforms in Kenya to determine which one's more on demand right now. But I'd go ahead and say follow your interest, follow your passion. Because when you follow your passion, some of the things you do here will not feel like work. When things do not feel like work to you, you'll end up becoming top 10%, top 1% in that particular career pathway. And whenever you're top 1% or top 10% in any career pathway, it's very hard to miss out on a job. So just keep that in mind. I would say don't focus so much on what's more in demand. Even if you want to become a geologist, probably it's not as on demand as computer science. But if that's something that comes easy to you and you feel like it does not feel like to work to you, you enjoy it, right? It's you are able to obsess over it more. It's very easy to end up being top 1% and you get a job off of it. But these are both in demand layers, right? So if you have the technical skills, you're going to get the job. You have to be good at it in the first place, but choose one that's more in line with your passion. So if you're a designer on this call, I'd probably say if design is more of your thing, probably attend our HTML CSS workshop after this, because that might be better suited for you, because now you'll be learning code and how code can be used to design websites and the like. So it's within your domain. If you're more into the mathematical layer of things, data layer, you're the type of people to analyze news and say, then this could happen here, or like this news happened, blah blah. So you already have domain expertise. You love the whole data thing and the likes, right? You're the type of people to enjoy Excel sheets, database, and the likes. Then data science is perfect for you. So once again, peg it on interest, but both of them are quite on demand or in demand. But if you want to really get a proper answer to it, probably we can do a scraping. All right, and then we can see that. That could actually be your first data science project if you don't mind.
Thank you.
Awesome. Okay, so I'll brush through some applications of data science. So far so good. We've said people can use it for business intelligence. So when people just want to know how to make better decisions for their business, I gave the example of Java coffee shops in the beginning. Product development is probably by far one of the most profound use cases of data science. Actually, these are two are the most profound here. And in big tech companies, in almost every team of developers working within a feature, there's a data scientist, because they want to make sure that the product or feature that's being built is quite in line, right, with the market. So the scientists are there to analyze the data, to look at usage, to see whether it's speaking value to people and whether it's making business sense to that particular company in the first place. So being able to analyze product features and the likes, the very significant layer of analysis. Most people in data science will end up getting jobs in these two areas. So business intelligence, which will be based on your domain. So you're probably doing business intelligence in a bank, you're doing it in a supply chain company and the like. So the domain could be profound, or you're doing product development, and this could be a product that's either a web app, a mobile app, or it could be a typical logistics application that you've built. So it doesn't always have to be the typical software application we're talking about. So those are by far most profound, because almost all companies need a bit of product development and business intelligence. At times for physical products, probably on product development, you're doing more of like industrial analysis. So you're trying to look at machines, efficiency, and the like. So people who are more into operational management as well might also understand that as well. For those of you in marketing, data science has become one of the most important layers of targeted marketing. Not only is it being applied in some of the tools we use, so how do I get my blog listed on the first page of Google? Right? So there's some sort of targeting. They look at that based on certain search terms. How do they choose what article to appear there as well? There's a lot of data science working on the end goal there, an algorithm to be able to predict what article would resonate with someone who searched this the best. But I think what applies to most people now is targeted marketing, whereby we do a lot of our analysis. We segment people into different interests, and you're able to target them and say that on Facebook, I want people who are interested in this, and that, because you've been able to predict that those are the people most likely to end up liking your project or your product. So it saves you so much on marketing, because the more targeted your marketing is, you don't have to be in front of eyeballs of people who are less likely to buy your goods. So you optimize your advertisements and promotions better, or your marketing initiatives. I've talked about health and medicine and how it can be used for predictions. One that I profoundly love is sports and gaming, where a lot of people are doing, a lot of people are now applying data science, particularly teams, to analyze players and predict whether there'll be a hit in the future or not. I know in the US there was something called the Moneyball method. Now, when we add data science to the Moneyball method, right? Moneyball is I won't talk about Moneyball. Our time is not that good over here. But if I'm a big club like Arsenal, right, and I've just come to Kenya, right, and I'm trying to find the best talent that could be the next Wanyama or Mariga, probably I'll go to a couple of academies. I give them wristbands, try look at movement of players on the ball in different positions and the likes. And because I have previous data of really good players and how they played when young, I can be able to predict which sort of 2-3 people out of these 10,000 people should I pick, because they have a high chance of becoming the next superstars, right, at the end of the day. Or when I just analyze the data that clubs collect on performance, like the assist, mini, like heat map of people. Think about the data people collect. For those of you who are into sports, you can imagine when you watch Sky Sports, the analysis they do, there's a lot of data they collect. So it's very important. That data is also analyzed to even by people who are into betting, to predict what sort of to go ahead and output what sort of odds they need to put in a game. In fact, the people who do the best analysis are usually betting companies, because they don't want to lose anything. So whenever you see the odds of a team winning is 1.1 and another one is, let's say, 3.0, keep in mind those people have done extreme deep analysis, and they know the likelihood of this guy is winning is this percentage to the T for them to do that. Now, of course, because it's a game of luck at the end of the day, the other team could end up winning. But you can bet if the game was replayed 1,000 times, right? The betting company would be right with that particular percentage that they were able to output. I think this one we've also seen with people who predicted almost all Euro games with 90% accuracy. The only games they missed are the ones that their prediction are very close, at like 60% this team to win and 40%. Those are the only ones they lost. But once again, betting is also a really good layer to get into. Transport, we talk a lot about driverless cars. It's not just about driverless cars, it's also about transport optimization. So I know in Kenya we don't have the best traffic light or traffic control system, right? But in other countries, data science has been used to optimize, right, the transport system, because we can already predict the number of vehicles that will pass in a particular road at any given time, so that we know how much to improve the flow of that particular road, or even we know when to increase the number of lanes or expand a particular road, because this is the typical data collected over time as well. Finance, very, very understandable. Risk and fraud, for those who are into it, I don't need to explain more on how that can be used as well, but we can use data science to detect fraud automatically without necessarily having to go through 1 million transactions per second to know what could be the fraudulent ones. We can just know that as well now automatically. Speech recognition, these are now the more niche areas. Image recognition, right, when you're starting to think of AI as well. Even natural language processing, how can I be able to analyze a paragraph written by someone and say whether it has a positive sentiment or a negative sentiment towards a particular thought as well. So these are more of the AI focus layers that come right after it. Any questions as we now get to the roadmap? Okay, Jesse, I know we have the next workshop in the next 5 minutes. I think we'll just keep this up, and I hope no one on this workshop is looking to get to that. But if there's anyone in this workshop who was also joining the HTML CSS workshop, just bear with me. We'll finish in the next 10 minutes. So you can always feel free to make the switch. But yeah, the invite should not be the invite should already be on your email. For those of you who signed up for both data science and software development, just keep that in mind. Now, let's go to the roadmap now. So how should one typically learn data science? So the first layer will be the data analysis layer. So what should I learn on the data analysis layer? So first layer is going to be learning Python programming. Python is by far the most recommended language here, programming language here. R is an alternative, but used more in academia. Let's keep that in mind as well. But the tooling that Python has been given to be able to do data analysis and machine learning is quite profound today, that it's by far the most used language by data scientists across different industries. So when you want to get started, the computer science layer, you can learn Python or R, but Python is the recommended language in this particular field. The second layer, as you want to become a data analyst, is understanding SQL data analysis. What is SQL? SQL is a querying language that is applied on relational databases. Let me explain better. Most companies today are using a relational database, which is SQL based, to store their data. When you go to the website of Zindua School at the moment, right, when you interact with that website, the content on that website is stored on a MySQL, let's say, database. Whether you signed up onto a learning management system, you finished course X or lesson X and the likes, it's all in a MySQL database. So if we wanted a data scientist in the team, the first layer of it would be an apt understanding of SQL, because the data collection layer needs to come from that particular database. And because a lot of companies use SQL databases or relational databases, it is essential to understand SQL, the querying language, and how to be able to do analysis with SQL in the first place. For companies that use no SQL databases, you should already know how to import JSON data into your Python into Python extremely easily, which is usually in the form of JSON, which you usually explore when you're doing Python. Not a worry, because even when you consume APIs, at times the data comes in as JSON. But the SQL layer is very important to understand the querying language for SQL. Whereas for NoSQL databases, that's a skill you get as you're doing Python programming. Okay. Now, once we are very good at the programming layer, we're very good at the SQL layer, now we can do Python data analysis. What does this entail? The first layer is being able to do data sourcing with Python. Now, while we can go ahead and download data most of the time, at times we have to consume data from an API. So how can you access APIs through Python? Second is we have to do web scraping whenever you want to get data from the web. Let's say I just want to collect data from all 1 million Jumia products. Of course, I'm not going to go page by page and write down this data. I can create a script to go automatically and get that data for me. So web scraping is a really a good example of this. And then the final layer will now be, how do you integrate your SQL databases to Python, right? So my SQL queries are here. I've been able to output this sort of results now. How do I bring this sort of database outputs into the Python environment? Okay. Now, once we have sourced our data, the next layer is now data analysis. And for data analysis, there's 2 libraries we use in Python. That's NumPy and Pandas. However, it's highly recommended to also think of SciPy because it's a core bonus that covers some things. A good example is something like outliers, or whenever we have imbalanced data. SciPy is the better library for it as well. So we do explore some things on the SciPy side to a significant degree as well. So NumPy, Pandas, SciPy will be some of the libraries you learn to be able to do data analysis with Python. And then the final thing now is we've been able to analyze our data, right? Pandas is this, like the analysis, like you've been able to analyze it as if you're in Excel. Now we want to visualize it, right? So how do we output graphs and the likes? And we have libraries for this. So some of the ones we recommend would be things such as Matplotlib, Seaborn. Those are probably the 2 most core ones. If you want to be able to do geo data such that we can put data in a map, then GeoPandas is highly recommended for you as well. So that's something I'd do it. As a bonus, you can also learn Plotly and Bokeh. Once again, we've underlined the most important layers of things you should be learning over here. Now, not every time will you be doing things in Python. And you need to understand, because companies work with tools, right? You don't always have to overcomplicate things and have to code up your visualizations at times. At times, a company already is using Power BI or Tableau, and these are probably by far the most common data visualization tools. And any data scientist, you need to understand how to use these tools in the first place, because not always will you be required to go ahead and do a visualization in Python, though you would do. At times, just the easier route is to go ahead and use a data visualization tool like Power BI and do it for you, or Tableau and do it for you automatically, because everything is well structured for you. So if you have a tool that's going to ease your work, go for it and do it. In the case where this tool cannot serve you, then now your programming skills apply, which can allow you to make more custom visualizations or make slightly more advanced analysis or way more customized, let's say, data manipulation on that particular front. But because a lot of companies use this, particularly if you want to get into business intelligence and product development analysis, so those of you who are going to work in typical data science jobs in companies as well, Power BI and Tableau are things you cannot run away from. I'd say learn one of the two. Power BI is starting to become way more popular because of the impact of Microsoft across different companies or Microsoft teams. And then the final one is now Microsoft Excel, right? So Microsoft Excel is probably the bread and butter of any business. And because the bread and butter of every business and almost all businesses have their data in Microsoft Excel to a degree, there's no way you can do without it as well. So keep that in mind. Don't run away from Excel. In fact, learn it to a significant degree that you can even use macros. You can even do, what do you call it? There's pivot tables and the like. So it's not just addition and subtraction on this particular front. It's learning Excel to a degree that you can do proper visualization, proper slicing, proper data analysis, right? Because in certain companies, you'll end up doing a lot of your data analysis within Excel and not even ever touch Python. Probably you'll end up doing data analysis where you just touch SQL and Excel, right? So you also need to make sure that you don't ignore the skills that you think are like, you only Excel, it's okay. No. It should be standard for everyone. Okay, if you have a question, just drop it on the chat. I'll be looking at it. Stephanie is asking, first, I'd like to apologize if it is out of context, but my question is, in terms of career growth, market need, and opportunities, what would you advise a person to choose between data science and software engineering? I think I answered that question, right? Okay, I did answer that question.
I have a question.
Yes, go for it.
What is an API? I'm having trouble understanding.
What is an API? Okay, awesome.
Yes.
Okay, so an API in full is called an application programming interface, right? Usually it's a way for you to interact with data from a particular application. So let me just give you an example. If today I'm the creator of YouTube, right? And on YouTube, I have a database of videos, I have a database of users, and I have a database of how users interact with these particular videos. Most of the time, I want to make my data available to other people, right? Such as yourself. Probably you want to do YouTube analysis of your own account, right? Or probably you want YouTube to integrate with a different application. So a good example is YouTube integrates with a couple of YouTube analysis applications that do like let's say listings of the best YouTube channels, right? Or they're able to also do like search engine like let's say I want to do search engine optimization. I'm a marketer, right? So I'm building a tool that's able to look at YouTube SEO to see that when someone searches this search term, what are the top 5 videos as well, so that we also know what these top 5 videos entail. But because you want people to build and integrate with your tool as much as possible, so they want to access some of the data in your tool, or they want to post, right? So they either want to write, which is like the post layer, or get data from your particular database, and you want this as a possibility, but you cannot give them database access, right? We cannot add them to a database and say, here's access to my database, you can do that. The way we do that is we do that using APIs, whereby we create an API. So a good example, it could be something like a REST API. So a REST API is one example of a particular application programming interface, such that using the REST API endpoints I've given you, you can get some of the data points that you want, right? So when you Google developers.youtube or something, or Google developers, and you look for YouTube, you will see API endpoints for YouTube, such that if I wanted to access, right, the top 5 videos on these search terms, I can be able to get it. And this allows people to build and integrate with YouTube, because our applications don't live in a silo, they have to interact with a couple more applications. The same way when you have to log in into different applications with Facebook. The reason why you can log into different applications with Facebook is because there's an active API connecting Facebook to that particular application, such that when you log in with Facebook, the API integration is able to push in your email, right, to the application that you've logged into, and they're able to also detect that you've logged in without necessarily you having to input your email again. So you can see, like, we're not living in a silo. That's a good example of it. So through an API, you can either post data onto a database, right? You can either get data from a database automatically without you necessarily having access to that particular database. And through an API, a company is also able to limit how much access someone has to their particular database or their particular content, right? So at times they might restrict it with an auth, so you have to authenticate yourself. At times they have rate limits on the API, right? So that's the other example. At times they've just defined certain endpoints which can only give you certain data points, so that you have access to not the full database but areas of that particular database. So that's what I'd call an API. Very, very essential, because that's the best way to interact with some of these tools, because you'll never ever get the database. I hope I've answered your question.
Yeah, thank you. Got it.
Awesome. Once again, when you're learning APIs, you'll get a more in-depth analysis of understanding of it when you're actually doing it. I think it becomes more profound when you're doing it. Okay, so for machine learning, the first layer is you need to understand the prerequisites of machine learning. Now, most data science programs, and I'm talking about data science programs outside a typical degree program, will not go through this prerequisite, because it's extremely difficult to go through a 6-month program that starts doing mathematics, right, and the likes, right? It's extremely difficult. So what do we do on this particular front? It's recommended that you either have a background in mathematics and statistics, right, so that you can be able to do machine learning to a very, very good degree. And if you don't, it's recommended that you can learn these things by yourself. I know it's not easy to learn math outside a typical school setup, but it's not something you can't learn. In fact, this is probably the most free content you can get out there. Whether you're doing three, is it 3 blue, 1 brown, or 3 brown, 1 blue, something like that. So there's a lot of sites, right? I even see Imperial College has a lot of these things available to the world as well. But mathematics and statistics is a prerequisite. So what type of math are we talking about? So definitely differential calculus will be at the core of it. Linear algebra, because we'll be working with vectors and matrices when you're building some of this, optimizing some of these ML algorithms. And then the other one will be convex and concave optimizations as well. That's more of the advanced math as we start thinking about things such as gradient descent, which is a very key concept of machine learning. And then the statistics, of course, the descriptive, usually almost everyone understands it. You also need to understand inferential statistics as well as probabilistic statistics. I think for those of you in the statistical field, you should be able to understand this. So things such as Bayes' theorem there and the likes. Do you have an apt understanding of z-scores and the likes? So statistics is a very key concept, because some of these concepts are applied, right, or almost automatically in some of the machine learning algorithms. I won't talk about that, but let me go straight up to the machine learning here. So when you're learning machine learning, the first thing you learn is supervised learning. So what does supervised learning entail? Supervised learning is machine learning whereby we are training our model based off of data that has both the feature and the label. Let me explain better. Let's imagine I have a data set of house features, but in that data set, it already contains the price the house sold for. So I have the features of the house, which could be it has 3 bedrooms, 4 bathrooms, then the tiling is wooden and the like. So I've written all those things. Hizo ziko hapo, and I've gotten the price of each and every single house, right? Now I can go ahead and model my data using this, so that you can be able to detect a pattern between the features and the price, so that I can get a regression line, such that the next time I only have the features of the house, it can predict the label, which in this case is the house price. So some of the typical supervised learning algorithms whereby we train with both features and labels so that it can make a future prediction of the label whenever we don't have it in the future is classification, where we are classifying things, or regression, where we are predicting more of continuous data. So regression would work for things such as pricing. Classification would work for things such as I'm trying to determine if this drink is beer or wine, and these are the features of it. So a good example. And the tool we use mostly for this will be scikit-learn for it. Okay. Any questions on supervised learning there? Okay, no question. Now, to understand supervised learning better, it's good to understand unsupervised learning. Unsupervised learning is that sort of machine learning layer where we are trying to make predictions here when we do not have, we're training our data without the label. Essentially, there's no label. Imagine I've just been given a house with features. There was no price, right? What can I do with that? Imagine I've just been given a couple of customer profiles, right? There's that, just a bunch of customer profiles and how they interacted with the tool over time. So for unsupervised learning, we're trying to optimize for different things. At times, we're either just trying to cluster out these people. So let's say an example is someone gave me data in a particular supermarket, right? I could easily just do unsupervised learning of it and then go ahead and realize that every time someone bought milk, they also bought bread. Then I can tell the supermarket, for you to optimize your sales, put the bread at the door of the supermarket and then the milk at the exit of the supermarket. So bread at the entry, milk at the exit, because people who buy milk always have to buy bread. By them picking this bread before they get to the milk, they'd have gone through the entire supermarket so that their eyes can see a lot of products and so that they can make some other random sale if you want to optimize our sales of it. So I can only understand that if I was able to do clustering where there's no particular target label, but we're able to start detecting and seeing patterns in data and start getting insights off of it. That's a good example of what we call association basket, right? That's used in supermarkets. And they use that to optimize the arrangement of goods to optimize sales in the supermarket. The other thing would be something like dimensionality reduction. So I have 1,000 columns of data, right? Probably these are 1,000 columns of data, but my rows are going to be about 1,000,000, which is fine. But then I have a constraint. It's computing power that I need to use over here to make some of these sort of predictions, or rather to run a regression off of this. It's going to take me a really long while, or it's going to consume a lot of money for me to run it on the cloud. But with something like dimensionality reduction, I can easily run a model to detect how much does each column speak to the variance of the data. Like how much additional value does each column speak to this particular data set, right? You'll always realize that at times some columns are quite correlated, that by like you don't need to have both of them. You can just combine them into one or have just one of them as well. So by doing dimensionality reduction, there's no clear label over here, but I can go ahead and output how much variability each and every single column adds onto my data. And then when I go ahead and realize that 95% of the variability of this data set is spoken by only 50 columns, then I don't need the 1,000 different features. I only need these 50 features. So this is also a way for us to optimize our algorithms as well. And you can see there's no label as well, right? You're just able to see an unseen pattern. So the unseen pattern is variability of this 1,000 feature data set is only contained in 50 features. So I'll maintain the 1,000,000 rows because I need more data, but I'll only use 50 columns instead of 1,000 columns. And that saves me a lot of cost, right? And time when it comes on to modeling. Cool. After that, it's hard to avoid time series data. So time series analysis with a library called SATS model is highly recommended as well, because most of the data we work with, if you're working in sales, you're working in finance as well, is quite time bound as well. And then you have things such as model evaluation and model deployment. Very, very important to learn model evaluation, model deployment. How do you know whether your model is working well or not, whether it's accurate or not as well? So being able to evaluate a model is a very, very core skill to understand. And then for those of you who want to focus on machine learning engineering or even data engineering as well, model deployment is a very important layer. So how do I push this model to a web app so that other people can be able to make predictions off of it? Okay, any questions on machine learning? Okay, no questions? Now let's go to the final thing, which are now the advanced concepts. So if you just do step A, you can easily become a data analyst. If you do step A and step B, now you can start applying for data science jobs as well. But you have a chance to go ahead and specialize. So one area you can specialize is on big data engineering, where you focus more on databases, you focus more on building big data pipelines to do real-time or batch processing of data. And the good example is the YouTube case. Let me give an example of the Uber case. If I ask for an Uber ride right now, the moment I step onto the app, it detects my location, right? So it's taking in data real time. Based off of my location, it goes and tries to map out the closest Ubers to me before it matches me to someone. So this is now real-time optimization of a particular application, whereby it does not matter how good you are at machine learning, if you, like without this sort of layer of making it come real-time. Probably someone built the model to match users to closest drivers, right? But how do we push it to production in a way that it's more real-time? So you'll end up learning more about databases here. You learn a lot about databases because you'll be working a lot on it. On it, you learn a lot about the tools that you use on to optimize this data pipelines. Some of them include Apache Hadoop, Apache Spark, or for real-time data streaming, Apache Kafka as well. The second layer will be deep learning with TensorFlow. So for those of you who want to get even deeper into machine learning, right? So for big data engineers, you enjoy more of the data pipelines. For those of you who want to do even more advanced modeling, you can go ahead and start learning AI now, which is the deep learning layer. Libraries recommended for this will be TensorFlow and PyTorch. I'm starting to have a really good, let's say, preference of PyTorch, right? I've always been a TensorFlow a person for the longest while, though TensorFlow is still slightly more popular in the market right now. PyTorch feels cleaner though. So some of the things you learn here will be things such as neural networks as well, right? How can you start doing image classification and recognition, right? How can you start doing natural language processing, right? So generative models is whereby how can we start getting computers to generate real images? You know, right now we're seeing tools such as DAL-E, whereby they're replacing designers. We tell it to design an image of a submarine with a rhino over it, and this is an unseen image, and it's able to generate it, and it looks very realistic, as if it was an actual photo as well. Those are some of the generative models. A really good concept to understand. I think that's probably one of my most interesting AI layers that I spend a lot of time on trying to just feel amazed at what we can do at this particular moment with generative models. Or reinforcement learning, which we're now starting to borderline on the robotics layer, or even when you're trying to train computers to start playing games. A good example, like with playing chess against each other and the likes. It's quite interesting, reinforcement learning there. So I don't want to delve deep into the explanation of this because of the time right now, but you can always go ahead and explore this once you have a apt understanding of machine learning, if that's where you want to kind of expand onto. Though getting deep learning jobs, most of the time, you need to have a graduate degree. So that's why you don't see it being covered a lot in boot camps. But you can always, like, if you work a lot in a machine learning role, it would be very easy to upskill into this because you'd understand the layers, you'd already have interacted with some of these sort of, let's say, neural networks as well to be able to make that sort of prediction. But most importantly, this is not even an advanced concept. It's a concept that everyone should learn, whether you're a software developer or a data scientist: cloud computing. At the end of the day, we are deploying all these things onto the cloud. And the three most popular cloud platforms are AWS, Google Cloud, Microsoft Azure. Regardless of what development you do, you need to know how you can push it to the cloud. So if you're a machine learning engineer, how can we deploy this to the cloud? If I'm a data engineer, how is my data pipeline, my big data pipeline, how is it working automatically on the cloud as well, whatever platform it is? Or even if you're a software developer, how are you making sure your web application is on the cloud at some point? Companies are using this. There's no way to avoid it. It's their way to go for it. Okay, so let's call it a day now with a final question. Any questions so far so good on the pipeline? So I'm going to finish it up. So I know I've thrown a lot of jargon at you today, and I don't want to leave you out for dead. And that's why we're going to go ahead and talk a bit about Zindua School. So why we do this is because we are fast, a part-time virtual coding school, right? And we offer programs in data science and web development. The thing that sets us apart is, one, we champion personalized learning. So you're not going to be learning through workshops like this. In fact, we only do workshops like this for free courses, but you get to work one-on-one with a technical mentor. The second layer is project-based learning, whereby you get to work on a daily challenge, a weekly project, and a capstone project. So you can imagine how much projects you have built in either route, right, if you are part of the Zindua ecosystem, right? Parallelly, the weekly and capstone projects tend to be the more weighty projects that are able to build your skills to a particular degree. Keep in mind, in this industry we are on, parallelly in tech, as much as people are saying they look at degree, most companies are impressed more at what you can build more than what degree you got. In fact, you could have the best degree whatsoever, but if your building skills are off, there's no way you're getting a chance at a solid job, because it's very easy. This the good thing about such fields is there's no gatekeeping based on I know this person or this other person. It's all about your skills. If I look at the project you've built, you explain it and the likes, we're able to see whether you're going to be a fit for the team or not. That's a good thing about this, both software development and data science to a degree. And the final thing is our programs are based off of industry certifications by Microsoft Azure and AWS. So students sit for these exams when they graduate right after. So let's talk about it. The most important layer for us is we believe that income should not be a barrier to education. And that's why we offer the best fees in the coding market in Kenya at the moment. So the first option people usually have is you can either pay for the program upfront or in installment. So because we break down the program into 5-week modules, right, you can pay in 5 installments, right, or you can pay it all upfront and save 20% of the cost. Once again, this will share with you. They're also on our website as well. But for students who cannot defy it, we have something called an income share agreement that allows you to learn now and pay later. So you can defer up to 50% of your fees if you cannot afford into an income share agreement. That's the option 2 there. However, for people who pay 100% of the program, because in an income share agreement, you pay nothing if you don't get a job. So we also try to give the same advantage to the people who paid upfront, which means you have a 50% money back guarantee if you do not get a job in 6 to 12 months after graduating as well. Once again, it's pretty much based with how much you're looking for a job. Some people we work with, because it's part-time, are probably still trying to finish school as well. So it's going to be variable, but we go ahead and say that after finishing the program and you've done the certification and it's been 12 months, so the part-time job will give you 50% of your money back off of it if you paid upfront. If you are part of an ISA, if you don't have a job, then you're not paying an ISA because it's pretty much pegged on your income. Okay. I've added this links to this sort of slides that you can always follow in, which is go to the website and learn more. You can learn about these financing options and the terms that go off of it. And you can also explore the breakdown of the data science program, which should be pretty similar to what we've gone through today. Pretty similar to what we've gone through in the call today. But I have some good news for all of you. Probably you guys already on it. You don't have to make a commitment already. If this is something you're still exploring, we have a free Python for Data Science Foundations course available on this link, zinduaschool.thinkific.com, that you can join in anytime, start learning a bit of Python programming, and decide whether you want to expand into data science or not. And this has no strings attached. You have to pay nothing. You're not forced to join the core program off of it. This course is actually, in fact, a prerequisite to the core program. So you can't join the core program if you've not done the free course in the first place. So we have it out there for you as well, such that those of you who are still new to this and are still thinking about it, you can explore it. For those of you who are not new to this and want to join the core program, I'm available as well. So you can talk to me after this particular call and you can see the way forward, and I'll share the slides with you. So that you guys can be able to apply if you want to join the core program, or you can join the free course if you want to as well. In fact, to make life easy, I'll just copy paste these links as well on the chat so that you guys can be able to join in for those who have not. So if you want to join the free course, that is the place to join the free course. So that's the link I've shared, right? If you want to learn more about the data science program, the core data science program, and apply, this is the link to our website page that's focused on data science. So for those of you who want to go straight to the core program. However, because you're going to share all these resources and we have an active Slack community, I recommend all of you to join Slack as much as you can. So let me just add the Slack link as the final thing. Join Slack. I'm going to send these slides on Slack actually as well. And on Slack, you can also DM me at any given time if you have questions and if you need support off of it. So my name is Cyril Machine on Slack. You can always DM me over there. When you join Slack, make sure to join the hashtag Forum Data Science. That is where I'm going to share the slides, and that's where we're going to keep having discussions on data science. Whether or not you want to join the program, we just keep that as an open forum for everyone who wants to chat data science. Now, with that said, let me take questions from the crowd.
Hi.
Yes.
How can one reach you? Maybe after, like, do you have an email address, like maybe a professional one?
Yes. So personally, you can reach me at cyril@zinduaschool.com. That's
sorry.
So I've placed my email over there, Cyril@zinduaschool.com. However, if you just want to reach out to any one of the team members just for general support, reach out to me for data science related issues. You're not so sure that you want to take this or whatsoever. But if you want general support, you can just do hello@zinduaschool.com so that you're routed straight up to the person who's better placed to answer you. So that's what I would say in regards to emails. These are also very, very available. On our website, we also have a phone number on our website just to make it easier, so you can always WhatsApp messages as well.
All right, thank you.
Awesome. Yes, Eunice, you're saying something?
I have a question.
Yes, Eunice
No,
was
it's
talking.
Umi.
No, it's Umi now, yeah. Go ahead.
To say thank
Okay, Umi, I can't hear you so well, but I heard you say thank you. So welcome very much. Thank you for attending as well. I hope this spoke value to you guys. And I hope for those who are beginners, the free course will be a good starting point. I don't know, Umi, whether you have anything else to add because I can't hear you as clearly.
Just
Okay. I don't know whether the problem is my connection or Umi, but you guys can tell me. But what I'd go ahead and say is, Umi, if you can just type down on the chat so that I can understand exactly what you're saying, that should be good. Or you can stay behind after this call as well, so that we can chat if it's more personal. But if you can type it down, if it's going to help everyone, please do, because I can't hear you so clearly. As you're waiting for that, any other question? Okay, no other questions. Thank you very much, guys, for attending this. I hope this was valuable to you guys, and I hope that I'll see some of you on our core data science program, or I'll see some of you learning Python programming on the free course as well, wherever thing. Even if you just want to go ahead and get started online by looking for resources, you now have the curriculum to follow. So if you want to learn by yourself, well and good. If you want to learn in a community with the benefits we've talked about over here, you can join us. If you just want to see whether this is for you, you can join the free course. The links are there. Please join the Slack channel because that's going to be the easiest way to reach me, right? Because I'm usually on quick dial over there, so you can always message me and get my response on a particular thing, or get quick support from me, or get forwarded someone else, because everyone's there. Everyone in the community is there, from students, alumni to team members. So it's a really good portal to be on as well. So thank you very much, guys. Enjoy the rest of your night. If you are part of the people who are joining the HTML CSS workshop, sorry I've taken 30 minutes of the workshop, but you can still feel free to go join it. I think the link should be on your calendar if you're here, if you registered. If you don't have the link, just stick behind and I'll add it to the chat after this call, and that should be good. Thank you very much. Have a nice time. I will send a follow-up email with all this stuff, but the best way to get the follow-up is on Slack, which I'm posting immediately when I leave this call. Enjoy the rest of your night.